edition of the Professional VMware vBrownbag. We're doing these on Tuesdays. We're calling them sack lunches because we are coloring outside the lines. Instead of our typical VMware-based menu, VCP, VCAP, storage, network, this, that, and the other, we have on the line with us tonight a Brian Dorsey. Did I say that correct?
Absolutely.
Oh, no? Okay. Brian Dorsey can be found on Twitter as @BrianDorsey. I believe that's the right Twitter handle. We've been communicating with it all day. And if it's not, well, that's rather embarrassing. Before we get too deep into things, some quick notes to get in on the conversation. Our Twitter hashtag is vBrownbag. Please abuse the heck out of it tonight. We are going full-on interactive. And because this is being recorded, I may have just implicated Mr. Brian in answering questions every time this episode gets watched. And that's fine too, because there's a good core community that monitors that vBrownbag hashtag after hours after the show. So ask any questions you have there, and we'll try to get you to a correct answer. We have APAC, EMEA, Latin America, and U.S. brown bags. I'm not going to read the slide to you, but they are all going on and all doing something new and interesting. Like I said, our guest tonight is Brian Dorsey, and I'm your host, Cody Bunch. And, with that, let me know when you want me to change the screen over to you. But if you could, just give us who you are, a little bit of background, and then we can go right into Q&A too if you want.
Absolutely. So, hi everyone. My name is Brian Dorsey, and I'm a developer advocate for the Google Cloud Platform. So I've been doing that for a little over 2 years, and totally excellent to share my Twitter handle. It's literally my job to talk about Google Cloud Platform. So, and so also, take everything I say with kind of that perspective. It's definitely the platform I know the best, and the perspective I'm coming from with a lot of these comments. So, call me out where I say things that are not true or confusing, or I leave things out, all that sort of stuff. I think we heard a little earlier from the previous episode, if you caught that, from Terry, kind of an overview of the whole Google Cloud Platform. So I won't do that today, but I probably will do a quick overview of Compute Engine. Dive into, I've got a list of things that are interesting and/or potential places to where Compute Engine is different than a lot of other virtualization environments. And then we've also got a list of things from Cody that are likely of interest to you folks, but also we're going to be on Twitter and make this really interactive as we go. So where do we start? Do we just dive straight into the overview? I want to take this.
Where is it? Let me send the presenter thing to you.
Excellent. I would like to show my screen. Okay. And we can go ahead and hide that in theory. Hopefully everybody can see that. What I've just showed is the Google Cloud or Google Developers Console at console.developers.google.com. And this gives you an overview of all the cloud stuff you're using. So we have this web interface, and so actually all of the cloud APIs, we have a web interface and a command line tool called gcloud, and the actual APIs are available over HTTP JSON with OAuth 2 authentication. So our web tools and our command line tools hit the same APIs that you guys use. So everything I talk about today or show today, either through the web or the command line, you can do the same thing via code as well. So that's all fun. So I guess the first thing is at a high level, Compute Engine is virtual machines hosted by Google. So if you know virtual machines or if you know operating systems, you're basically right at home, and you can set up a machine running any operating system. We have some images that we provide by default and have some agents on that make some things a little easier, but you can also build a custom image directly from scratch, upload a tarball, and actually boot from there. So you can support operating systems that you can run operating systems that we don't provide an image for, things like that. And so at the core, it is virtual machines, networking, and disk, all APIs set up there. It's kind of, in some ways, it's kind of the usual thing. Everything that people used to do at a data center. You like get a new computer, you put a disk in it, you connect it to the right switch, you turn it on, all that stuff. There's APIs for all those things, and I'm sure this audience is very familiar with the benefits of virtualization as a whole.
Yeah. So in terms of image building and APIs and so on, that includes third-party tool support. Do you know offhand if there are any Packer providers for GCE?
I believe so. We've got a group inside of Google that is kind of trying to make sure that we have good support for all the kind of popular open source tooling for building images and running and configuring clouds, provisioning things. So I know for sure there's Chef, Puppet, Ansible support, things like that. I am not completely sure about Packer off the top of my head, but I believe so.
It seems like it would only be a hop, skip, and a jump anyways. What else did I want to ask? So you had said VM, it's all virtual machines. We're familiar with the concept and so on.
Yep.
If I remember right, and from some of our email threads going back and forth, that is. Hold on, I may have a small crisis to deal with. Just a moment.
So I'll kind of go forward there. So you've got your regular virtual machines, networking, and disk kind of stuff. We have these organized in different failure zones, or actually probably not the right word, but different zones and regions. So each of the zones is a kind of an isolated domain. So if something goes wrong in that area, everything should not be affected in any other zone. So we have 3 regions overall. We have the U.S., Europe, and Asia right now, and we have multiple zones, at least 3 in each of those regions. And in fact, I know there was a question of exactly kind of where those are. So if I come over here to cloud.google.com/compute/docs/zones, we get kind of the full details on that. So we have actually 4 zones in the U.S., 3 in Europe, and 3 in Asia right now. And we actually even have on this page exactly where those are. So Council Bluffs, Iowa, Belgium, and Taiwan are where these are.
Does that actually include like the maps address of the data center?
Let's click on this link and see where we go. So we've got pictures, visit the FAQ. Does not look like there's an actual address, but I'll bet you could figure that out.
I figure it wouldn't be too hard to discern, but posting the address of one's data center is generally kind of scary, especially as big as Google is. Like, that's a big old target too.
Absolutely. All the data centers are well documented, and they work very hard to keep them safe.
Yep.
We
talked last week about cloud.google.com/security was just launched the same day we were talking. So the question I had, and I'm not sure if you got to it or not, is we were talking a little bit, not just availability zones and whatnot, but like virtual machines is a concept, but you guys do it, Google does it a little differently than say KVM or ESXi or Xen, right?
And the base underlying technologies are fundamentally the same. The difference, I think, is that we are running them at Google data center scale, and so there have been some places we've kind of started with KVM, and then under the covers there's adapting that to Google data centers and making all that kind of work really well there. We've added live migrations so that in each of our zones we actually have them carved up in even kind of smaller areas than that, and so we actually schedule maintenance on sections of a zone at a time. We'll take a whole section down and update the BIOSes, update, replace hardware, like do whatever is needed to make the host happy, so that the hosts are always being kept up to date. And when we do that, we use live migration to actually migrate the virtual machines off into other hosts to clear out that area, and then kind of do that around the whole zone. And so you can have a machine running in a zone for years, and it might end up running on different hardware without you ever even knowing it. So also probably something very familiar to the VMware folks.
That's actually pretty neat.
Yeah, it ends up allowing our data center folks to be really on top of things all the time, and at the same time giving you very long-lived stable machines.
Huh.
So that's going on. And another kind of fun thing that I think the the data center location conversation is kind of interesting. We were lucky enough on our team to get a tour of the data centers, and every disk that's in these data centers is actually, all the data is encrypted before it's written to disk. So even if somebody were to find out where the data center is, get a job there, get access, go in and take a disk, all the data is actually encrypted, and there's as far as we know, there's no way to get access to any of that data.
That's actually super curious then. In addition to, not in addition, but I'm having trouble Englishing tonight. I'm sorry. Is that per instance encryption, per host encryption, per tenant? How are those keys managed?
Right. So key management is all handled on the cloud side, and we don't go into a huge amount of detail on that. And we definitely know that there are folks who would very much like to manage their own keys. So if that's you, let me know. It would be interesting to kind of talk through use cases there. But we effectively manage keys so that we're not reusing them. So I can't go into too much detail, but basically our security folks have vetted kind of the key use policies to make sure that all the things are encrypted and that nobody can have kind of cross project or cross access to any of these things. Yeah, probably can't go much deeper than that.
That's fine. So another question came up is, besides live migration within a given zone to keep VMs online,
yep.
In the event of hardware failure, so power supply loss, something of that nature,
yep.
Do you restart the VMs automatically?
Oh, right. So there's actually a policy for that when you create the VM on what you'd like to do when something that we truly couldn't predict happens. CPU fails mid.
I see you have a tab open that looks like it belongs to create a VM or so.
Exactly. Yeah. Should we walk through that?
Sure. I think that might answer and open up a whole bunch more questions all at the same time.
Exactly. It will absolutely open up some fun questions. So I was going to do that. So this is our cloud console, and so right now you can see there's kind of some overview graphs, and you can kind of add and remove which ones make the most sense for you. All the compute stuff is grouped together here under compute, which right now we break down as App Engine, Compute Engine, and Container Engine, which I think I'll be back in about a month to talk about in detail. That's the Kubernetes project. So in Compute Engine, one of the things we can do is look at the VM instances, and in a way, I guess that answers your question you had earlier before we started. Is it VMs or is it instances? Instances kind of
instances. Yeah.
At least there it is. So we often say instances, and to be honest, it's a little bit of a non-specific word because we also use instances for our Cloud SQL and other things. But virtual machines, instances. So I might make a vBrownbag instance, and oh, right. So we get some helpful feedback that it needs to be all lowercase, so we'll do that. And here's where I can pick the zones. I'm going to go ahead and pick a zone in the US. We basically kind of break the machines down by a balance of how much CPU to memory you want. So, and then kind of size up and down from there. So in our kind of standard balance, you can start from 1 and go up to 32 cores per machine. So we can go ahead and create a 32-core machine there. If you need your processing you're planning on doing, this VM is either memory bound or either CPU bound, you can save some money by kind of balancing the machine out to have more or less of one or the other. We can go ahead and pick that. The disks is a whole other fun conversation that we should make sure we do, but at the basic level, you can go ahead and pick from one of our pre-made machines here. So the default kind of Debian is, our kind of most commonly used base image here, but you can also play with one of the CoreOS images. You can use CentOS, Ubuntu, Red Hat, SUSE, and a couple different versions of Windows Server, which is good. And I'll go ahead and pick Debian there. We can do some basic firewall settings here, and then there's a bunch of other settings we can do kind of at the project level. One of the things that's kind of fun. Go ahead.
Under the basic firewall settings there, what ports are allowed by default? So beyond, like if I don't select any of those and we just go on from here, what's open by default?
Yep, by default, port 22 for SSH, and actually I need to look at the docs. It may be that we're leaving the Windows RDP port open by default as well, and it may be that you need a tag applied to get that open.
Okay.
And all of those rules are actually over here in networks, and we can go poke at that and see. On my project, I think I may have a fair amount of noise of extra things in there, but we can take a look at that.
Okay.
What this is actually doing under the covers when you set this is it's actually going to set a tag, and tags are just kind of a common delimited list of text, and that's actually how the firewall rules map to instances. So you might have a tag that's front-end web server or database server or things like that, and then you apply different firewall rules and access based on those tags. And the tags also show up in the API, so you can do kind of whatever you need to from there.
Okay.
And the startup script here is kind of the kickoff point for any kind of machine setup you want to do right after boot. So we basically have a hook, so you can put a bash script in here directly, or you can put a URL to one to download. And that's the very first thing that'll get run on this virtual machine the first time it starts up. So what that lets you do is basically kick off whatever tools you already use to manage machines. You can kick that off here, or you can write a simple script that's like apt-get install Apache,
or the Bootstrap script for your config management tool of choice, something like that.
Exactly. Tagging, which is up above, is mostly used for networking stuff, but you can also set arbitrary key value pairs on the instances. And this is useful both for kind of managing your machine, so you know what they're for and who's responsible for this thing. But also it kind of non-obviously it lets you parameterize an image. So if you've got an image, so all of these metadata keys are available inside of the virtual machine as well. So you can query this metadata server, find out the value of these things, and decide to do different things. So you can use this to, for example, configure which database to connect to, or in a even more extreme version, what role is the machine? How should it configure itself? Pass some parameters down into your configuration management systems, that sort of thing. And now we get down to this automatic restart is what I was just talking about. So when a machine fails for some reason, should we restart it automatically or just kind of leave it off? So you should decide that at startup time or change it. And that's also related to the on-host maintenance. So I talked about instance migration. So it's an opt-in, or actually it's on by default, but opt-out, yes. So if you just don't want to have that ever happen, you can turn that off. And preemptibility is super fun. So we've got a whole conversation about pricing stuff. So maybe we should come back to that. But that's basically kind of temporary machines for doing work that are far less expensive. Save you a lot of money. You can have multiple disks attached to all these things. You always have a boot disk, but then you can have additional data disks and the like.
Those additional disks, do those, how? All right, so many questions.
Yes.
Let's start with what is the transport mechanism? Is it iSCSI, or is it like just a disk mount on host? How is that?
Right. It's exposed to the host as a volume that you can mount using regular Linux tools, or a volume that shows up in Windows. So the operating system sees it as a block device. We have three different categories of these block devices. So our default is, we just call it persistent disk, and it's a network attached block device that's distributed across that whole section of the data center. So every block is going to be on multiple machines, and we work really hard to give very, very consistent performance on these disks. So they are fast enough and reliable enough that we consider that the default. They're fast, they're better than spinning disk locally. So that's our base offering. We also offer SSDs over the same kind of network attached SSD, and there's also an option for if you really need the absolute highest performance, you can do local SSD as well.
Okay. So the Spinny Disk with distributed blocks and so on.
Yep.
Is there how much of that is magic, and how much of that can we talk about?
It's all magic. No. So what that is at a high level, and I can refer you to a talk from a couple years ago at a Google I/O where one of our senior engineers goes into quite a bit of detail actually. But it's logically in the same general family of algorithms as kind of arrayed kinds of things on the blocks, except it's going out of the network and working across multiple machines. And when we find hotspots, they might end up on more machines than blocks that are rarely accessed. We try very hard to make sure that one of our goals with all of Google Cloud is kind of reducing variability in latency. So we might not always be the absolute fastest on a given metric, but we try very hard to have smooth, non-spiky graphs. So when you build a system and it works a certain way today, you can expect it to work that way tomorrow, and under different load categories and in different regions and zones and that sort of thing. And so the persistent disk is kind of tuned along those lines.
Okay. And so because it's distributed, I don't necessarily have to worry about, say, a host failure taking it out
Absolutely
and so forth.
Yeah, there's no single host that can take down a persistent disk. Yeah.
And that distributed, that's not getting distributed across 10 hosts in one cabinet in a computer room. That's
absolutely
several hosts across several cabinets. You guys have this I/O talk has a lot of
yeah, it has a lot of kind of general scale there, but you should be thinking in terms of thousands of machines rather than dozens. In terms of distribution of these blocks.
Okay.
That sort of thing. And the thing I should mention about the disk that is surprising, and it's kind of related to the thousands of machines comment, is that the disks in Compute Engine, all of the persistent disks, larger disks are faster than smaller disks. Just let that sit for a moment. So larger disks are faster than smaller disks. So when we normally think about individual disks, you buy the disk and you get a chunk and you get a certain amount of I/O with that, right, and a certain amount of storage. Mm-hmm. And you can use all of the I/O no matter how much storage you're using, right? And if you start thinking about having thousands of disks, the only way to get more I/O in aggregate across a whole data center is to add more disks. And when you do that, you also get more storage, right? So these two are tied directly together. And so we decided to make the billing of this also tied directly, and part of this is around giving consistent performance to everybody across the whole data center. So when you need a certain amount of I/O, you provision a disk of a certain size, and when you need a certain amount of storage, you provision a disk that's big enough to do that, and you'll get plenty of I/O.
I think I heard it. I think I heard the answer to this question there, but let me get it clarified. Is the local SSD option, is that a persistent or a non-persistent disk?
So it is. That's an excellent. I am actually a little unclear on the life cycle of persistent disks. I may need to read about that and get back to you.
Okay.
That is a little crazy. They do live migrate. So I think. Oh darn! So you found a hole. I don't know the answer to that question. Yeah, the persistent disk and persistent SSD definitely live off of the host. Local SSD by its nature lives on the host. We do live migrate it, so if we do need to migrate the machines, we can do that. The local SSD as well. So you have access to it for the normal lifespan of the VM.
Okay.
What I'm not completely clear on is there's a separation when you've got regular persistent disks. You can have disks that live far beyond the life cycle of a normal VM, right?
Okay.
And so you can completely delete a VM, and you can have a disk sitting there, and you can create a new VM based on that disk, connect to it again. I'm not sure how that works with local SSD.
Okay.
So
That's fine. We can get a little bit deeper into that on like we have you on in about a month's time, right?
Yep.
I'm sure the answer exists out there either in the docs or in the I/O video or something of that nature.
Yep. Yeah,
so
that'll be one to look for in the docs. It comes after the I/O video.
Okay.
And yeah, so just to repeat that because it's super important. Like if you start doing benchmarking and things, like you start like looking at porting an app or doing a trial, you want to make sure you have a disk that's big enough to get you the I/O that you want out of it. So there's that. And networking-wise, by default, each of the machines has an ephemeral public IP address. You can also create them with no public IP address, which limits the networking, internally, coming in, but also has some limits kind of going out. And you can also set up machines so that by default, the software-defined networking doesn't allow machines to kind of impersonate others and pass traffic on. But if you're actually running VPN software or proxying software on a machine, you might want to do that. So you can turn IP forwarding on.
Okay. On the networking point, IPv6 is that here? Is it coming?
So we are all IPv4, which is kind of an interesting state for a company that's so into IPv6. But as far as Compute Engine goes, we are all IPv4 at the moment.
Yeah, so this is where I ask the, you don't have to answer, but I ask the obligatory, like where on the roadmap is that question? Right?
Totally. And I don't have anything to share there on that. Sorry.
Okay. I'm okay with that. We had one more question come up, and I think we can get to that when we get to the create button, but I want to make sure I get it out there. I'll just repeat it verbatim because I may be missing some of the context. Go GCE instances run in Omega? I assume so, since they don't run under Borg.
So sounds like this person knows all. I don't know. There's some assumptions in there. I'm not going to talk to exactly which particular systems these are running on in terms of internal scheduling stuff. We'll say that it's definitely all running. All of the virtual machines are actually running in containers on our internal container scheduling stuff. So won't really talk Borg versus Omega or what have you, but they are in fact all running in containers, kind of in Google's internal container formats, running on our distributed infrastructure, which becomes kind of a little interesting when we start talking about containers in VMs and the like.
Yo dog.
Exactly. Definitely huge users of containers at Google, and it's one of the ways that we are able to get the utilization numbers that we do in our data centers that sometimes show up in some of the the docs about trying to be as ecologically friendly as you can, trying to have efficient data centers, we do carbon offsets for all of our power, and try to use as much green power as we can. But part of that is just trying to be as efficient as possible, which I think in many ways everybody with a lot of servers is trying to do, and containers are one of the key ways we get there as far as we have. So let's work the rest of the way through this create dialog, get this going. So this security tab is pretty interesting. One of the things you can do when you create an instance is basically just create a username and actually, sorry, I've got this a little wrong here, but you can paste an SSH public key line in here and then get a user created for you automatically that will, if you've got the private key, you can authenticate and log in as that user. By default, we have some project level stuff set up so we can show logging into this guy, and there's also a web way to log in over SSH. And we also have this thing called service accounts throughout Compute Engine. Actually, this is kind of true across. So basically, these map to, this is an internal, this is a user account, but for Compute Engines, like for this particular instance. So this, you basically give it OAuth scopes. Whether or not you want to be able to get info on that user, you can give it access to the Compute Engine API, including write access, so you can have an instance that's allowed to create other instances. Whether you have like access to cloud storage, which is our blob store, a bunch of these different cloud APIs that you can get access to. And basically, whatever OAuth scopes you assign to the instance at creation time, there is an OAuth token that is available from the metadata server at all times. So any of the software running on the machine can grab that token and be authorized to do all of these things within your project.
Does that token change? Is that persistent for the life of the instance?
So it's actually it's an access token, and it does expire, I believe, every hour or some number of hours, and okay. It is automatically refreshed for you as part of the metadata server. So if you decide to, like, if you're using the gcloud tools or any of our auth libraries, so it will automatically grab that as it changes from the metadata server. If you write your own code to do that, you will, like, if you do get a failure, it doesn't work anymore, you just need to go grab a new token and retry.
Okay.
And that metadata server shows up as metadata.local, .local, I think.
Here I am trying to hit the back button in your console.
Oh, sorry.
No worries. There was something really, really neat at the. If you just want to hit.
Oh, you're right. I meant to mention that. Okay, let's do another one. So we've got our foo instance here that is all that, and this down here is this what you're thinking of? Okay,
yes.
So you go through and you walk through this whole dialogue that we've just done, right? And you're like, oh, that's nice, but I want to repeat that. So you can hit this command line button and get the full detailed gcloud command line that would create exactly the same image that we just did. So boot device name, like the actual name of the thing, which project it's in. And if we go change, to a different instance type and then click this again, it's actually updated as the command line.
Wow.
So it keeps that up to date the whole time. Yep.
And that also does it for the REST stuff as well. So if you
exactly.
Oh my gosh.
So this is the actual yes, exactly. So this is the actual JSON doc you could post to the Compute Engine API. In fact, this exact URL that would create this instance. So assuming you've got a valid OAuth token, you can just curl post and whoop, a machine will start coming into being for you.
So those two options. Now I have to ask this on a global Google Cloud side thing. Are those two options fairly pervasive throughout all of it, or is that just really well documented for Compute Engine, but not necessarily networking or App Engine?
It's mostly on the Compute Engine side, actually. As a side point, I just wanted to mention that this machine is already up and ready to use over here. This is actually running. It's run through its startup scripts and it's up. Doing whatever we asked it. But yes, that little particular part there is mostly in the Compute Engine section of things here. It is though in various different parts. If you want to create a disk, we've got the command line for doing that. I think it's all the way into the networking side of these. Right. So even if we want to, so all throughout the Compute Engine stuff, so the networking and the this exists. And it's, so really good eye there. I thank you for calling that out. I meant to talk about it.
That was Mr. Kyle called that one out, but I think that is outstanding. That is a wonderful little, oh my gosh.
And it really helps the kind of discovery. Because GUIs are good for kind of poking around things and figuring out how they work and what the possibilities are, and just kind of navigating a new space. But it's terrible for automation, right? And so this is a nice bridge between those two.
GUIs are good if I need one. command lines are good if I need 100. APIs are good if I need 100,000.
Right.
Yeah. Oh, yeah. That breaks down, like, command lines are good for 100,000 and APIs are good for 1 or 102 and yada, 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 right? But without getting too philosophical.
You're tempting me to try a demo live that I haven't tried in months. Let's see. See if I've got this. Oh my goodness. This could be crazy. Let's go ahead and log into this guy. So this is a total experiment, and it's actually a very old code base, so it's entirely possible that we'll go off the rails here. But what this is it's a demo of just starting a lot of machines. So I'm just gonna pick 100 here, and hopefully it's all configured using my right project and the like. So I hit start there. It sent a request off to the Compute Engine API, and it started then a polling in the background. Each box represents one virtual machine. Gray, they haven't yet kind of made any significant progress. Once they start turning blue, or yellow, they've been allocated. Blue, they're starting to actually get the image out and starting to boot up. And once they get to green, then they are good to go and starting to serve traffic. So this is basically just kind of and we skipped blue, in fact. So this is just an example of if you need 100 machines to do some work for you, it's pretty fast to get these up and going and ready to do your thing. And yeah, like you said, this is when you want to use the API. And so these will come up pretty quick. The other thing to note, and this is kind of a fun place to start talking about billing a little bit, I think. So we do a couple of things that are very unusual and I think really help out in the kind of managing costs world. So minute 13 seconds, and we've got 100 VMs up, and we're ready to go. In fact, let's go find these and prove that they really exist. So we can come in here to a different project that I've got and look at our VM instances. And yep, there we go. Our quick start instances. All of those guys are real computers running in Asia, ready to start doing work. So that's pretty cool, right? But 100 machines cost money, so probably want to stop all those guys. And when we do, so first off, we bill by the minute with a minimum of 10 minutes. So if you're doing builds on a virtual machine, if it runs for 10 minutes or 11 minutes, then you get billed for 11 minutes, not an hour. So it really makes kind of treating machines as more ephemeral things without trying to do a bunch of scheduling work on your own end, really a lot easier to deal with. And then on kind of the opposite end of that, when you leave a certain machine type running for a long time, it actually it costs less money to just kind of leave things running, right? So we pass that on as sustained use discounts. So we give a discount kind of up to around 30% of the overall price, I believe. It might even be lower than that now, of the kind of total price. Let's go ahead and look at pricing as it is today. And get a sense of the sustained use differences. But so this will end up dating this recording because prices are always changing, right? But for a single core machine that would normally be a nickel an hour, so 5 cents an hour. If you were to use that for a whole month, then it's 3.5 cents for the whole month, just automatically. And this is actually by machine type. So if you have a whole bunch of N1 standard ones coming and going, you still get the sustained use discount actually, over the course of the month. So if you have a minimum of 10 running for the whole month of different machines, you'll get that sustained use discount on 10 of those. So it's a little tricky to kind of talk through and explain about that, but the bottom line is that you can actually kind of just not worry about it, and when you use the machines a lot, you'll get a discount on it. and that's really nice. And there's no contracts or forward planning or anything else there. And then on the other hand, when you know, when you've got a lot of big computation to do, but you don't actually run by a specific time, or you've got some flexibility in that, you can run a preemptible machine. And a preemptible machine will never run for more than 24 hours, and it might get shut down with a few minutes notice at almost any time in favor of a standard price machine. But if there's space in the clusters, you can run a machine for far less than the regular price. So right now, the sustained use price is 3.5 cents for one core machine, and it would be 1.5 for a preemptible machine per hour. Yay, pricing. But basically all of that is there to hopefully make it far easier for you to kind of work on the part of the system that you're most invested in and just trust that the pricing is going to work out well.
Okay.
So let's see. We've talked about, so the other fun thing to kind of point out here in the UI, which might not have been super obvious, is that we're looking at machines in, these are all in the same region actually, but they're in different zones. And if we make a new instance in a different region, all of the machines are showing up in the web UI. So you get to see your usage across your whole project, no matter where that actually runs. So that's pretty fun. One of the things I was kind of most excited about using VMware on the desktop was having snapshots of disks, right? That just, it changes everything.
Rollback. Yeah.
Yeah, so snapshots rollback, like it completely changes your interaction with a computer, right? When you can snapshot it and go back in time and make copies of things and all that sort of stuff. And so our persistent disks also offer snapshots. So if you call a sync or what have you to get all your writes down, call the snapshot API, it'll return within a few seconds, and then the snapshot continues in the background, and you can make changes to the disks, and everything is all consistent and happy and good to go. And then these snapshots are actually global objects, so you can make a new persistent disk from them in any region, any zone in the world.
That's actually pretty awesome. So as we're bumping up to like 10 minutes to go, there are a couple of additional, like we could probably do another 2 or 3 episodes just on this to cover, like there are vast swaths of functionality that we're not going to see tonight. Some of the things I am particularly interested in,
yep.
Let me save the complicated ones for another time, and let's can we just poke on the networks off on the left-hand side?
Absolutely.
We were talking about how tags associate to firewall rules. So a couple of questions. Are those firewall rules handled at the VM layer or at the container shell just outside, or is IP tables on the host?
Actually, they're logically kind of outside of, they're at the project level. They're logically at the project level for your entire set of machines. In practice, it's actually data center level firewalls that you're configuring here.
The data center within
so it's kind of like
still
both
within my project though. So like my border is my project.
Your project,
right.
Exactly.
Okay.
Yep. So you're affecting the traffic, and these firewall rules are all incoming. It's mostly locked down by default, and you're opening up access to particular ports on particular machines. It's pretty much locked down by default. All the machines have outgoing network by default. There is a mechanism for setting the next hop, so you get to decide what to do with all of the outbound traffic from a machine. So you can basically set up a proxy server that runs your own rules and that sort of thing. But by default, outbound's all open, and these rules are defining what's allowed into the machines.
Okay, and these are stateful firewall rules.
So these are, they're not doing any deep inspection kind of thing. So when you're talking about stateful, specifically, you're thinking about kind of like between multiple packets kind of stuff, or?
That was just the question: is are these stateful or stateless?
Okay, so these not being so we'll hit an edge of my knowledge here. I'm sure the asker has a very specific question that I'm not hitting directly, but let me say some things and see if I cover them. These are the networks support TCP and UDP, and they are allowing traffic to instances. We can also talk about load balancers a bit, but these are not determining which machine gets the traffic. Each machine has an IP address, and it's like whether or not that traffic gets in to the machine. And we're not doing any kind of protocol specific deep packet inspection, or like, so these aren't HTTP aware firewalls and that sort of thing. If you want that kind of dig into the TCP packets and say, oh well, if it's HTTP, only allow it if it's these conditions, then you need an extra layer of firewall.
Okay. He clarified and said, no, if I open an inbound rule, do I also need to open a corresponding outbound rule to guarantee answers?
No. So by default, outbound is all allowed. So unless you set up the kind of forwarding through another VM, which has its own which can have its own rules, by default all the outbound traffic is allowed. So that's to answer that. And when I clicked through here, I kind of like jumped through it. So you click on networks, and the first thing you get is you get some static IP addresses, and then it looks like there's not much there. You can have multiple logical networks within your project. It's fairly rare to have that set up, but you can. And by default, everything is in the default network. So when you click on that, that's where your firewall rules actually are. So if you come back here in a month or a week and you don't see it, click on the default, and that's where the rules actually are. And like you can see, I actually have far too many here set up. I've got some that from a workshop I was running and from Kubernetes Road things I was running before, and I've added, just widely opening 8000 and 8080 and, let all of my machines listen to port 80 and all that kind of stuff, which, this is more of a playground kind of project where on a production project you would have things more specifically set. This one's kind of a good example. This is one of the default ones. So this is kind of here by default, and it allows, from any IP, TCP port 80 traffic, but only to instances tagged HTTP server. And under the covers, that's the mechanism that checkbox when the create instance actually uses. It just adds this HTTP server tag when you say this one should, be able to be a web server.
Okay. Now, do I go somewhere in particular and manage those tags, or do I create them arbitrarily as I go?
So you can kind of make them up as you go, and so you can decide. Maybe you have a code name or names for your different parts of your application. You might name them on that. Based on that, I don't think I created one here, but you can go in and edit the tags later on an instance as well. And by changing that tag, you actually change logically which kind of network groups it's in, and that sort of thing.
Now, when I do change that tag and change those network groups, is that change instantaneous?
Instant is always a strong word, but it's very quick. It's not something you have to wait around for or kick a process or something.
That's what I meant. Is do I have to wait? Is there a Reaper process that catches those once an hour? How big?
It's not. It's in the scale of seconds, not minutes or hours. I haven't measured it with a. I guess that might be a fun experiment to try. Is actually set up an instance that doesn't have 4080 open. It has a web server and sit there in a loop and see how long that takes before it hits. But it should be pretty quick.
Okay. The last one. Oh, so you have two different sections for load balancing, and
let's talk about that real quick. I know you've got other stuff you wanted to hit, but we have two different load balancers. There's this thing we call the network load balancer, and so this is basically the network 5-tuple the source port, IP and port, the protocol, and the target IP and port, and they kind of end up on the same machines. But sorry, that's kind of going a little too deep. But basically, this is a kind of a round-robin load balancer that you can point it at groups of machines. So, and then you can have health checks for those machines. So the healthy machines will actually be included in the load balancer, and machines that go unhealthy, where that's usually defined as an HTTP 200, somewhere on that machine. coming back on a regular basis kind of usually defines health. So you can pass these on. And these networks, network load balancers, are any TCP or UDP protocol, and they are at the region level. So you can spread traffic across any of the zones within one region and do that. So they have a static IP address, and traffic is routed back to this group of machines. We also have this thing called HTTP load balancing, and this is HTTP only, and it will spread traffic to machines across any of the regions and zones we have. So you can, and it is actually just to a pretty good degree aware of where the traffic is coming from, and it will actually kind of route to the closer of the zones, depending upon where the request is coming from. But it's HTTP only. So that's the quick overview of those guys.
Okay. Honestly, let me look at my notes here. What other questions did I have? All the rest that I had open were like, I don't know that we could get to it in the next 10 minutes.
I can expand on one of them real quick. I talked a little bit about the disks. All the data is encrypted at rest. The same thing is true for like all the network connectivity. Both between machines and that sort of thing. So basically, whenever bytes are in transit or written to disk, we encrypt them on our internal networks and disks.
Well, now that is interesting. Yeah, I had things like architectural considerations and design, like GCE design patterns. If I'm building an app for GCE, like how do I optimize building an app for GCE? And like that's a question we could probably spend all night on.
Totally.
So, with 5 minutes to go, is there anything you're dying to show us that we've just straight up missed because I'm a bad host, right?
That is so not true.
No, I'm an okay host. I'm a mediocre host. You should hear some of our other guys, right? Like the rest of the team is outstanding. I'm the pinch hitter.
So a couple of things that are kind of fun and might not be directly obvious from an auditing standpoint, which I think is probably interesting to a lot of your folks. We actually post as part of the API, or make available as part of the API, all of the kind of high-level actions that happen on a project, and which particular node is affected, which users are doing it, that sort of thing. So that can be very useful. Let's see. Let's also just check and see if we had any other questions in our GoToMeeting.
Nope.
We're all good there.
Popped up, and
Okay.
nothing left on the Twitters either.
So I might make a little teaser about running containers and the like, and do a few minutes on that if you're good with that.
Okay, that's fine. Let's roll.
Let's roll. So Google Cloud overall, you have a couple of options for running containers, and basically they all end up running on top of Compute Engine in the end. So all of the same kind of performance things I mentioned kind of hold true for running containers wherever you do. If you're familiar with App Engine, there's now a kind of another backend mode, a module type in App Engine called Manage VMs, and you can feed a Docker file to that and have that actually run on Compute Engine. So that's one angle. And then another angle is we've released an open source project called Kubernetes that is specifically made to help make it easier to run lots of containers spread across lots of machines. So basically to help you focus on your application, kind of like almost at the whiteboard lines and boxes level of granularity, and let the scheduler handle where to actually run the containers, how to get the traffic to them, how to help them find each other, all the things, how to do logging the same way, kind of get the network connectivity all hooked up, all the things you run into when you start, you decide containerization is awesome and you run lots and lots of containers. So just trying to help you kind of treat your entire cluster as if it's, one logical computing device. And I'll be back in about a month to walk through that and talk about that sort of thing.
That's outstanding. And like we touched on, I think that wraps up all of the questions for tonight. I now know a lot more than I did an hour ago, and I'm hoping the audience is very much the same way. So I'm a learner at heart, and every time I start to touch a new technology or get introduced to a new technology, like I get this whole like little kid glee, like seeing a little rubber bouncy ball for the first time. You know, like when you watch it bounce the first time, like, oh my gosh, best thing in the world, right? So I'm certainly going to try to get my hands a little dirty in this later this week, and you know, like that REST API or the command line button is going to be super duper handy.
That's
thanks
fantastic.
again so much for coming out, and thank you and the rest of the team for letting us put together this. I think it's like a month and a half worth of, and and if we can get more of your time to go deeper into each one of these things, that would be amazing too.
Absolutely.
Once again,
Sorry. Yeah, so just one last thing, like, yes, we should please keep looking into things, and let's not end with this particular thing. So, like, let's chat on Twitter, and I'll try to help through. Like, whenever you're like learning something new, things get confusing at first, right? So I'm super happy to try to help navigate that now, and as this goes online and people are exploring things. So at Brian Dorsey on Twitter, and I'll do my best to help you out.
Awesome. Well, thank you so much. Thank you everyone for coming.